Awesome. Welcome, everyone, to our first enterprise series for how to do advanced techniques with LangChain. Uh, I'm going to kick us off. For those who I haven't met yet, I'm Julia, and I lead go-to-market here at LangChain. And we're really excited to do a series that speaks to a lot of the questions that all of you have around how to be really successful in LangChain. And so today we're doing a RAG discussion with Harrison, who I'm going to turn it over to in a minute, but it's top of mind for folks. Just some rules of engagement. Please ask questions in the chat. We want to make this interactive. And we're going to be recording this so that if you weren't able to join live, we can send you the link. But we are not going to be publishing this externally, so feel free to ask your questions, and only participants who are invited will be able to see. And with that, I'm going to turn it over to Harrison to say hello and jump into it.
Awesome. Yeah, thank you guys for joining. Excited to do this, and excited to do more of these as well. I think the space is moving really fast, and so we're kind of intending this to be a space where we can share kind of like what we're seeing going on, things that we're thinking about, things that we see other people working on and thinking about, and hopefully hear from you guys about what's working well, and also the questions that you have about any of the things. So I have some slides that I'm going to use to kind of like guide the conversation on our end, but again, would love to hear kind of like this is on RAG in particular, and so would love to hear what's working for you guys in Retrieval, what's not working, what questions you have. Feel free to drop them in the chat, and Julia will kind of like pull them in as we go along. We want this to be the most informative as possible for you guys. So I'm going to share my screen. You guys should hopefully be able to see this. And I'm going to go into full slideshow mode. All right, awesome. So yeah, so today we're going to talk a lot about retrieval augmented generation, RAG, the state of it, everything to do with it. The general pipeline that we see people doing is, and probably what a lot of you folks are doing is kind of like split in this ingestion bit where you first index and ingest a lot of documents, and then the querying bit where you incorporate that into the LLM to generate an answer. And so for today, we're going to focus on those two parts, and then we're going to also focus on a few kind of like advanced techniques. This will be a combination of kind of like, this will be a bit more kind of like advanced than just going over the general bits. And for the general bits, we'll also provide kind of like a bit of an opinionated take on what we see working, on what we see other people doing. And this is in particular where we would love you guys to chime in as well around what you're seeing and what you're seeing work well. Starting off with the pre-processing bit. So this is kind of like loading data from various sources into some text format. We're seeing that there's two main components here. One's kind of like the connections to all the data sources. We've got a lot of them in LangChain. We've also integrated with a lot of partners who do this more full-time. So we've done some integrations with Airbyte recently. They have a bunch of interesting data sources, in particular on the tabular side. Unstructured IO, which I'll talk a little bit more about later. They also have a bunch of kind of like sources. And then there's a few other folks. I think like Appify does a bunch of kind of like cool web scraping things. And then one of the big things that we've been working on internally is web scraping as well. So like HTML parsing, everything related to that. We've seen that as like one new, and I think like the reason why a lot of people are using that is a lot of up-to-date information's on the web. And a lot of what people are using LangChain to do is to connect it to up-to-date information. And so being able to interact with the web is really important. Besides connecting to sources, the next big step is kind of like pre-processing and cleaning them. As I mentioned, we've spent a lot of time doing this for HTML recently. So we've got a web scraper, which we've used in some projects that I'll highlight later on. That's pretty good. The other really only big kind of like player in the space that we see here is Unstructured IO. So if you guys haven't checked them out, you absolutely should. We integrate with them on a lot of parsing and cleaning fronts. And they do a really good job of a bunch of different file types. So PDFs, Word documents, emails, all of that.
And Harrison, we have a question from Addie on how much you need to pre-process. Do you always need to strip out the raw text from HTML, or is sometimes leaving it in its raw format preferred?
I think what we've seen is it's generally it can work with raw text. It's generally a small improvement to parse it out. The area where it starts to become a bigger improvement is when you can then fit more of it into the context window. So if you have a bunch of like HTML tags, that'll just take up a lot of tokens, and so you won't be able to fit as much into it. And so I think like it's a way of focusing the language model on what really matters. That being said, if like you don't want to parse the text, if parsing the text is too difficult, the language model and the text is small enough, you can probably pass that in directly. Those are kind of like some heuristics that we're seeing. Chunking. All right, chunking next. So this is I think one of the big things that we've focused on from the beginning, and we've gotten a lot of questions about how big should the chunks be, how should you do the chunking, things like that. The default way that we have in LangChain that we recommend people to do is the recursive character text splitter. So this is not the first one that we came up with. This originated a little bit more down the line. The basic idea is that you split it hierarchically. So you'll split it, if you have like a markdown file, you'll split it on like header ones, and then within each header one section, you'll split it into header twos. And the basic idea of why this is important, rather than just splitting like every 1,000 characters, is it will keep more relevant context together. And so that's been powering a lot of our text splitters. We've added versions of those that split on code-specific tokens. So like HTML versus Markdown, Python versus JavaScript. We've got I think 15 or 16 different like MIME type specific splitters. We've also added functionality where you can keep the things that you split on either in the text or not in the text. So for example, if you're splitting on like new lines, you might not want to keep those in. If you're splitting on like a header, or a better thing might be like a Python like function definition, you might want to keep that in the splits. And so we're adding some functionality there. And one of the things that we'll be working on and adding over the next month is better support for tracking the provenance of chunks. And so what I mean by that is like, what parent chunk did this come from? What is the start token? What is the end token in that parent chunk? And we'll start to do that by adding kind of like a parent ID and then these start and end tokens explicitly. And that can be useful for some of the retrieval algorithms on the query side that we'll talk about later. We added a cool playground to play around with chunking. And then our friends at Nuum AI, which does a lot of this indexing, they're a managed indexing service. They added a playground on top of it that also adds in some of the pre-processing bit. So I think this is a pretty nuanced and also like heuristic driven area. And so we've tried to add some playgrounds to make it more exploratory. On the embedding side, we're seeing most people use OpenAI embeddings still. This is one area where I think the open source models are actually just as good as a lot of the proprietary models. I don't think there's too many reasons that people are using OpenAI over like a Hugging Face embedding model, aside from the fact that it's behind an API and it's easy to use and they probably already have like an OpenAI key. But this would be one of the first areas where we're starting to see folks use and get better results by using some of the open source embedding models. And there's some good leaderboards on Hugging Face to check out. We're also starting to see people start to fine tune some embedding models, and we'll be doing some work with Chroma around this in the next few months to basically improve the retrieval bit if you are using some semantic search. Vector stores are a big topic of conversation and one of the more important and used components in LangChain. We obviously integrate with a bunch. What we're seeing is there's a few different, there's maybe like 3 different types of vector stores that people are using for a variety of reasons. The first would be, okay, cool, you can see my mouse. The first would be kind of like this category up here of kind of like open source and specifically like locally running dedicated vector databases. So if you want to do something kind of like quick, you don't want to set up a remote server, you want to store these vectors in memory or in some format that can be serialized to disk very, very quickly, We're seeing a bunch of usage here, especially Chroma and Qdrint are pretty easy, very easy to use, off the shelf ways of doing this. Then the next thing that we're seeing is these kind of like more hosted and managed service that are dedicated vector databases. Here, most people are using Pinecone. That's kind of what we're seeing out in the market. And they're adding features that I didn't even know about. So I did a webinar earlier Tuesday with Andrew from Shortwave, which is an email client, and he was talking about how Pinecone has a lot of awesome support for namespacing under the hood, which lets you keep kind of like a lot of vectors in different namespaces. So I think they faced some scaling issues earlier in the year, but I think from all accounts, a lot of people seem to be using them, and that's working fine. The other category of vector databases that we see people using are existing databases that have now added in vector search capabilities. Probably two of the main ones here are Postgres and then Redis. I think Postgres is obviously one of the more popular databases out there, and so we see a lot of people just using it for convenience. And then Redis has really lent into the vector search thing, and so they're pushing pretty hard and adding a lot of functionality here and are also widely used. And we see those kind of being like the three main areas or types of vector databases that people are using. I don't think there's necessarily one that's better than others. I think they're for different purposes. Like I think having an in-purpose vector or an in-memory vector database that you can get started with really quickly is really good for prototyping and is really useful. And so honestly, most of the time I use Chroma when I'm putting together like notebooks and things like that. When I want something that's persistent, that's maybe when it's time to switch to one of the other ones. And I guess a lot of the consideration there is if you already have a database like Postgres or Redis, it might be easier to just use that. If you don't have any and you're starting from scratch, generally the UX for Pinecone or Weaviate or a vector native database will probably be a little bit better, so it might be easier to start there. Really curious to hear from you guys on what people are using, what they're seeing success with.
And Harrison, we had a question on if we've seen any vector databases be particularly strong at being time series aware. I think we're going to go into that a little bit later on Retrieval, but anything you can share there on time series awareness?
Yeah, we actually did we actually just did an integration with Timescale DB, which I think we did not put on the slide, but I think they have some good kind of like time series support. In general, yeah, I would say that's the only one that maybe kind of like jumps top of mind. We haven't benchmarked this rigorously, so I think that's.
Yeah, ClickHouse is also really good for time series data and as well as timescale.
I also see some comments around Azure Cognitive Search, and I'll also highlight Amazon Kendra as kind of like a similar like fully managed kind of like retrieval thing, and this kind of this is a kind of like an alternative to a vector store that maybe offers some other support as well. We do see a lot of enterprises using those for scalability. I think Google has one as well for scalability reasons, for kind of like reasons that they already exist kind of like within deployments. And so the reasons that's not on the slide is those aren't like pure vector databases or they're more like full end-to-end managed solutions, but we do see a lot of people using those as well. So this is this touches also a little bit on some of the more kind of like advanced topics that I'll kind of talk about. But one of the things that we see a trend towards in the past like month or so is this idea of not just ingesting one embedding per chunk. And so to break that down, like the way that it traditionally works is you'll split the text into chunks, and then for each chunk you'll create an embedding. You'll store that embedding in the vector store, and then at query time you'll look up the query. You'll create an embedding for the query. You'll look it up compared to one of those chunks, and you'll return that chunk. We're seeing in a few cases that it's actually desirable to create multiple embeddings per chunk, and there's a few different scenarios where this is useful. One is where you basically have larger chunks, and then you create an embedding for a smaller chunk within that larger chunk. And the motivation for this, rather than just splitting on those small chunks specifically, is that when you pass the text to the language model, you actually want to pass a lot of context. And so if you split them into small chunks, it has the benefit of making that retrieval, the embedding similarity, really good, but it has the downside of losing a lot of context. And so we see, and so we have this in LangChain, we call it like the parent document retriever. And that's a specific scenario where you'd create smaller chunks, create embeddings for those chunks, but have references back to like a parent chunk at the end of the day. Other places that we see people doing this are to basically, instead of embedding the chunk itself, embed maybe like questions that the chunk, use an LLM to generate text that could be questions that the chunk could answer, search terms that you'd want to this chunk to kind of like result in. And the idea there is, if people are familiar with HIDE, hypothetical document embedding, it's almost the reverse of HIDE. So HIDE is when you have a query and you use an LLM to generate a hypothetical answer, and then you use that hypothetical answer to create an embedding, which you look up in your vector store. And the idea there is that you're basically transitioning between two different kind of like state spaces in the embedding space. One where you have the queries, and then one where you have the answers, and oftentimes like questions and answers just have different semantics and can be answered differently. And so by creating these like hypothetical documents, or in this case, hypothetical questions, you create a bunch of hypothetical questions, you embed those questions, and then when relevant questions come in, you're now looking up similar questions and returning the chunk that corresponds to those. And then the third thing that we see people doing here is just manually creating vectors corresponding to questions that should answer those chunks. And this is a really good, albeit manual, way of fixing like misses. So fixing cases when you should retrieve something, but you don't. So if you have a document and a question comes in and you expect that question to retrieve a certain document and it doesn't, one way to fix that is create an embedding for that question and then store that in the vector database with a reference to that document. And so that in the future you will. And so this is a bit more of an advanced technique, but one thing in ingestion that we see people starting to do more.
Harrison, there seems to be a lot of moving pieces on how you can get better results. We mentioned a few here, trying different vectors for your chunks, maybe trying to store smaller chunks and do embeddings on those, or maybe even fine-tuning your embeddings model. Where should people start, and how do you progressively like layer on more sophistication?
I think people should generally start with the standard flow of kind of like create chunks, one embedding per chunk, retrieve those, pass those into the model. That's like the, there's a workflow for getting that up and running in 5 lines of code. I think it'll get you 80% of the way there, and it will let you it'll let you get 80% of the way there, which I think is really valuable. Like one of the things that we see people kind of struggling with is in some sense like product market fit for their applications. And so being able to iterate and being able to get new applications spun up really quickly to test that product market fit is really important. And so I would 100% recommend that you just get started with like the 5 lines of code thing. Then once you start seeing interest and you really want to perform it, that's when I dig into what's going on. And debugging kind of like RAG applications. We maybe should have added a section on that, or we can maybe do this as a follow-up one. But there's 2 big kind of like edge case or causes for RAG applications doing bad. One of which is you just don't retrieve the right information. And so if you can kind of like, so basically what I would do, get started with the 80% kind of like vector search, hook it up to Langsmith, which we'll talk about in a bit, start tracking thumbs up, thumbs down for your applications. Then you get cases where it's failing. And so then look at all the thumbs down, go into the traces, and then try to see, is it an issue where it's retrieving the right context and the LLM just messes up? Or is it an issue where it's not retrieving the right context? And so now you'll have a bunch of real world examples where it's not retrieving the right context. And this is when you can start experimenting with parent document retrieval, some of the hypothetical document embeddings, and you can really drill down. So yeah, that's a little bit on how I'd recommend getting started.
Yeah, that sounds good. And just a footnote, let's show how you actually retrieve parent documents when we showcase LangChain at the end.
Yes. Last thing on the ingestion bit is this idea of keeping knowledge fresh. So as a real concrete example, we launched Chat LangChain. Chat LangChain is chat over LangChain's documentation. LangChain's documentation, as you may be aware, changes basically daily. So it would be really good if it's kept up to date and kept fresh, right? And so we've added some utils to do that and do that in a slightly better way than just kind of like re-indexing everything. Yeah, the key bit here is we're adding kind of like these utils to help with change management. So avoid writing duplicated content in the vector store, avoid kind of like rewriting and re-embedding unchanged content. And so this is the indexing API that we expose with various cleanup modes where you can kind of like delete documents according to either to a few different modes, and you can do this in incremental mode. So you can do this kind of like, oh, I've got like 3 updates. If any of these 3 pages were in there before, like let's clean up those 3 pages. Or you can do it in a full mode where you have the whole like known universe of documents that are coming in, and you want to clean up any ones that aren't seen in that batch. So get rid of kind of like unseen documents. And so this is something we added about a month or so ago, maybe a month and a half ago. And we use it in Chat LangChain. It's parallelizable. It makes it so that you don't have to like delete your index and create a new one because it's always live. It does it incrementally. It saves time on embedding and saves costs on embeddings as well. And so as you go into production, I think things like this become more and more important. Moving on to querying. Yeah, so talking a little bit about the querying bit, which naturally touches on kind of like the prompts and the LLMs. And this is probably a larger conversation, but what we're largely seeing is OpenAI remains the most popular. There's a big interest in trying out kind of like smaller task-specific models. We've added support for a lot of different model providers and model hosting platforms in LangChain. And so it should be pretty easy to try some of those out. We're also working on bringing those into the playground in LangSmith, and so we'll have some exciting announcements next week around adding more support for different models. Up until now, it's basically been OpenAI and Anthropic, but we'll be adding more support for other models that'll let you easily try out different models for different prompts. And then the last important thing here is just prompt construction is still really model specific. And what that means is basically a prompt that works for OpenAI might not work at all for Llama 2 or something like that. And so this is something that we're thinking about how we can kind of like best help people switch between models and switch their prompts. And so the hub that we launched has tags where you can tag different prompts that work with different models. So you can explore kind of like what are people doing to make it work with Llama 2? What are people doing to make it work with Anthropic? Things like that. This is a pretty fast moving space as well, so we'll try to remain on top of this kind of like model interoperability. Yeah, so talking about some of the also advanced kind of like query mechanisms. So we come back to parent document retriever, which is this idea of embedding small chunks. Small chunks are good for similarity search, and then you retrieve larger chunks, good for generation. And these larger chunks can either be like the whole document, or they can just be like a page out of the whole document. So a slightly larger chunk, but not necessarily the whole document. And so we added this 2 months ago or something, and so I would recommend trying that out. Another thing very related to this is the context window kind of like discussion. Like context windows are increasing. This makes it possible to pass in larger amounts of text, which is why parent document retrieval is now interesting, because you can now retrieve these larger chunks. Getting a lot of questions about kind of like, what large context windows mean, when should you use them? What we've seen anecdotally is that they're good at retrieving single facts, but often struggle with reasoning over multiple facts. So as a concrete example of this, if I ask a question like how do I use this particular integration of like the LangChain code base, if I retrieve 20 documents and it's in there somewhere, it will probably pick out that single integration because we have documentation for each integration. If I ask something more complicated, like how do I use Anthropic with ChromaDB to do an agent that combines 3 different things. And so even though all the context might be there, if I pass in a lot of it, it might not be able to reason as much. And so that's where kind of like um, doing some smart things, which I wonder if we talk about later on. Yeah, a little bit related to self-query and basically generating queries to look up. So generating 3 separate queries and then looking up specific things like that and only retrieving those information rather than like opting for a wide set of information. That's where that can still help. There's been some research around this as well. So there's just Lost in the Middle paper that came out that basically shows that LLMs, if you pass in a lot of context, they kind of like forget what's in the middle. So they'll remember what's at the beginning and what's at the end. And that's why you'll often see, and different models have different kind of like strategies related to this, but this is why you'll often see questions at the end. So like have the context first and then the question at the end. This is what Anthropic recommends. And so, we expect as the models get better, these problems will kind of go away. But I think the general idea of really just only fetching the most relevant documents and really grounding only in that is impactful as well. Talking about self-query, this is the idea here is basically you have a question that comes in, and maybe that's part of like a chat conversation, maybe that's part of some additional context. And rather than just embed that question directly, you create a query or a set of queries and or some metadata filters that you want to use to look up. And this is really powerful because if you have a conversation and there's a question, that question could be referencing things that happened maybe like 1 message ago or 2 messages ago. And so if you just embed that question and it has like a pronoun up to there, you might lose sight of like what it's actually asking about. And so this is really, really important to do in chat conversations. And so Chat LangChain, which we launched 2 days ago or something, this is what this does for all follow-up questions, and this is what Perplexity does. We'll have some cool kind of like deep dives on how Perplexity does their retrieval stuff next week. But under the hood, as far as we can tell, they're doing this kind of like requerying bit as well. And then there's also this bit of generating the metadata filter, which basically means that oftentimes vector stores have metadata associated with embeddings. There was a question about like the timestamps in there. So like a question could be a question that needs this filtering could be like, what did Julia say about self-query yesterday? So yesterday is a specific time filter that you want to apply. And so you can use the LLM to generate that time filter as well as generate the semantic bit. So like self-query, and then you can pass that into the vector store. And so we've added this for kind of like the 10 most popular vector stores that we have. And if it's not available for the one that you're using, let's definitely chat. This is one of the big things that we're excited about and pushing on. All right, and finally, talking a little bit about some of the advanced techniques or more kind of like out there ideas that we see people doing and that we're excited by. The first is this idea of agents, and I think there's a few. Things here. One is basically using the language model to decide when to look things up and how to look things up. So in most RAG pipelines, you'll take the user question and you'll just pass that. You'll create an embedding for that directly and then look things up. As kind of like mentioned previously, that might not be the best idea. You might want to look up kind of like specific search terms based on the conversation. And so there's that bit as well. And then adding in another bit, sometimes you might not need to look things up at all. If someone says hi, you can, the bot should just respond hi back. You shouldn't necessarily have to look up information. Likewise, though, if it's asking kind of like multi-hop questions, you might want the bot to look up something and then look up another thing based on the results that it got. Or another use case is look up something. If it sees that there aren't any good results, try a different search query as well. And so giving it more autonomy on kind of like when to do this retrieval step. The downside of this is that it starts to get quite slow if you're doing a lot of these retrieval things. And so one thing that we've noticed is that people are more and more creating kind of like a UX distinction between slow and fast, kind of like chatbots. So if we look at Perplexity again, they have their Perplexity chat and then they have Perplexity Copilot. And those are two distinct things. One, in fact, you have to pay for. That's the Copilot. That's the more expensive one. And under the hood, we haven't looked into the Copilot much, but it's definitely doing more of this like agent type thing of deciding like how many times to query, what to look up. While the chat is more, it's more fast. It's like always looking something up. Maybe there's a rephrasing step at the start, but it's always looking something up. And so they've very purposefully created these two separate UXs, which had it's not like either one's necessarily better than the other. Like it can sometimes you need fast kind of like responses, even at the cost of some like accuracy. While in other times you really care about accuracy. And so creating this like separate distinction and separate UX is one thing that we've seen people do to create better product experiences.
Harris, I mean, we talked just recently about how having a very large context window can be challenging for an LLM to reason about multiple facts. And so you might want to break it up into smaller problems. Do you recommend kind of keeping a chain to remember state of all of those interim smaller problems that you've broken up, or can agents be more versatile here?
Probably depends on what probably depends on how much flexibility you want. So if you know that you always want to answer questions in a particular way, then having a deterministic chain where you specifically keep specific state that you know to be important to the next thing, that will probably be more efficient, faster, better results. But the benefit of agents is that they're really flexible and they can handle all types of questions. And so if you're more concerned about just having a general purpose kind of like chatbot and general purpose agent, then I'd recommend going that route.
We also had another question in the chat. A lot of times users don't give the full information needed to be able to answer a question properly. So sometimes an agent might have to prompt to ask for more information. How do you recommend injecting that kind of reasoning to ask for help into one of these retrieval agents?
Yeah, there's two things that we've seen people do. One is just better prompt engineering around the system prompts for the agent. And then the other is around giving the agent a tool specifically where they can ask for clarification. I was actually playing around with this yesterday, and what I noticed is that with GPT-4, if you give it like a semi-good prompt, it just knows that it should ask for clarification. So if you're using GPT-4, I'd recommend going with prompt engineering. GPT 3.5, on the other hand, if you give it tools, it likes to use tools. And so sometimes it will just go ahead and use tools, which in oftentimes is like a retriever or something like that, without verifying that it has all the right information. So if you're using a simpler model like GPT 3.5 or GPT 3.5 Instruct, then it might actually be beneficial to add this tool where it's basically just responding to the user to get more information.
Maybe one more follow-up question to that. I think understanding the model and what its strengths and weaknesses are is really important to the approach you're taking. When do you see people kind of testing multiple models? Is it still in the development phase, or should they get to some product market fit first and then reconsider choices later?
Yeah, it's a good question. I think both is kind of the answer. And so what I mean is there are some models that are better than others at certain things. So Claude has a really long context window, longer than the OpenAI one. So we see a lot of people wanting to experiment with Claude when they're doing a problem and they're just wondering, hey, instead of doing all these fancy things to avoid context window length, can I just shove it all into Claude and get an answer? And so that's a really good time to experiment with Claude, and we see people doing that. And then there's also some like code specific models that we see people wanting to experiment with. They're doing code specific things. And then the other one would be sometimes there's external forces that force people to experiment with things, like they don't want to send their data to OpenAI and they want to use something like Claude that's maybe available via Bedrock or an open source model that they're running locally. And so, there you don't really have any choice but to experiment. On the other hand, I would definitely say that OpenAI's models are the most performant, specifically GPT-4. And so if your goal is to get performance, and I think so basically, the biggest blocker we still see for most people is their applications just don't work. And so for that, I'd recommend diving deep on GPT-4, the exception being if long context window might help a lot. So dive deep on GPT-4, and then when you get something working and you're worried about going into production, cost, latency will start to become factors. But I'd start to think about it then, because if you can't do it with GPT-4, you're relatively unlikely to be able to do it with smaller models, would be my very practical advice.
I'm gonna read one more question out loud. We use conversational retrieval agents. Maybe we're doing it wrong, but seems like we can return document in the retriever, but not score. And we often like producing the generated output along with the document and its score, which requires a second ping to the vector store.
Yeah. So for the retriever bit, that's something, yeah, that's a good point. We should probably add support for returning that as some sort of metadata associated with each document. We have that on the vector stores. And so there is kind of like return with similarity scores that returns that for each document. That's not exposed at the retriever level. One thing that I recommend there is, if you're kind of like interested in that, we've started writing a lot of our chains and agents in LangChain expression language, which is like this declarative, easy to modify way to create chains, and we have some examples of doing this specifically for RAG applications. And these chains can work with any functions. They don't necessarily even need to be a retriever subclass. So if I wanted to do that exact thing that was just mentioned there, I would use LangChain expression language. I'd create a function, or I'd create a function that wraps a vector store and calls this like similarity search with score method and returns the documents with the scores, and then formats those explicitly. That's how I'd recommend doing it. The LangChain expression language we really added to make it easy for people to take the default chains and move beyond them and customize them, because again, I just mentioned you can get maybe 80% of the way there, and you should start by just getting 80% of the way there and seeing if there's product market fit. But after that, you might want to do customizations like this. That's why we added LangChain expression language. I'd check that out, and I'd start using that over the given kind of like chains. This also works for agents, because I know the original question was about conversational retrieval agents, you can pass in. Also for agents, you can pass in a tool that returns anything. So you can actually just use a standard agent and pass in a tool that itself is just a function that calls the vector store with the similarity search and score under the hood. Awesome. I think I chatted about this a bit before, but basically this trade-off between fast and slow retrieval. One's not better than the other. One gets you a faster answer at the cost of some accuracy, and so we see people do that sometimes, and then other times they want more, so they start to use an agent or some multiple lookups or something. The general paradigm for the fast one is the first question, and this is we'll do a blog post next week, kind of like reverse engineering Perplexity and what it's doing under the hood. But the first query to Perplexity, they just pass that directly to their search thing, as far as we can tell. And then after that, they start to rephrase it. And so if you notice, follow-up questions on Perplexity are sometimes like 1 to 2 seconds slower, because they have that rephrase step where they're calling a language model. Time-weighted retrieval is something that's kind of come up here and again. I think the first time that we really saw people doing it was actually the generative agents paper, but it started to become more and more a thing. The standard thing here is use some combination of kind of like semantic similarity and time decay. So maybe fetch like the 100 most documents and then do a re-ranking step where you take into account some time decay. The time decay can be based on this is where it starts to get a little bit application specific, but we see people doing it on the published date of an article or a piece of text, the last update on a piece of article, a piece of text, the last time it was fetched. This is different than time, but like the number of fetch counts, so like the popularity of it. And so there's this basic, and this kind of gets into the idea of a re-ranking step, where you do some standard similarity search, get 100 or so things, and then whittle it down to 5 based on some re-ranking step that starts to incorporate time or importance or something like that. this is often really, really application specific, and this is another good reason to use the LangChain expression language things and just plug in a function that you write as the retriever, because there's almost certainly going to be a bunch of custom code and custom logic specific to your application that you'll want to encode. Graph databases are something that whenever we do something around graph databases, it gets a lot of attention because they're really cool to look at. We don't see a ton of people using them specifically for their graphical nature yet. We see some folks using Neo4j, but they added like vector search capabilities within their graph database, and that's largely what they're using. We don't see a ton of people taking advantage of the inherent kind of like graph structure yet. There's probably a few reasons for this. One is it's more difficult. It's more difficult to set up. It's more complicated to query. And so even though it does have this nice property of being able to include have these like relationships between documents, we don't see people using like a full-on graph database for that. And I see a question on the screen, which I maybe just answered.
Yeah, I think we just answered it, but try to bring it back up. But yes, the question was around how often are people really using knowledge graphs in Retrieval or just vanilla RAG, and it sounds like more exploratory right now versus a lot of use cases. But I think people are pretty interested around it when it comes to like personalization or things related to like user entities, where you can encode some more information and relationships between users and maybe like items that you're selling or something like that.
Yeah, and what I'd also say is that there's maybe like vanilla RAG graph databases. There's a spectrum in the middle where you can start to take like hierarchy and relationships into account, but it's not a full-on kind of like graph database. And so even the example of like the parent-child retriever has this hierarchy between chunks in like the parent document that it comes from, and there's some like you could model that as a graph where there's like a before and after kind of like node. But we see people doing more kind of like maybe starting in the gray area or moving into the gray area rather than going full on kind of like graph database at the moment. Fine tuning is something that people are starting to talk a bunch about. It's not either RAG or fine tuning. You can use them in conjunction. They're actually pretty good at like usually different things. So we see people using RAG mostly for kind of like when they want to basically when the output needs to be in a specific format and or have a specific tone. So those are two big things where we see people using it. Less for retrieving factual information. And we usually see this layered on after prototyping. So most people prototype with RAG or few shot examples or prompting if they're trying to do either of those things, and then maybe eventually move on to fine tuning. And then the thing that I kind of want to end on is basically chat LangChain. We launched this Wednesday. We'll be launching some follow-ups around it as well. This is kind of like our attempt to codify a lot of things. So this uses kind of like the indexing API under the hood. So it's refreshed every night on a schedule. We've adapted this kind of like showing sources up front. So this is very much inspired by Perplexity. We've added feedback. It integrates with LangSmith. This is the actual last slide, but like LangSmith and LangChain work really well together. So if you haven't tried out LangSmith, you can log all runs there. You can log feedback there. You can debug things. We use kind of like a fast architecture here. So that means we don't have an agent. We're doing Perplexity Chat, not Perplexity Copilot. We cite sources inline and have hyperlinks to those sources. So being able to do that is something we've seen a lot of advanced applications do. And so this is one of our first attempts at kind of like building a good question answering bot over LangChain documentation. Again, it's a fast one, and we're working on some more involved ones. And this is, we're having fun playing around with the UXs as well. But I would highly encourage that you guys check this out. I think there's, I think there is a real place for fast and so slow ones. And so this, I think, is our best attempt at what a good fast chat application should look like, and hopefully it kind of like works for your use cases as well. That's really all I've got. So I'm going to stop sharing.
Yeah, just also call out people. Maybe Harrison, share your screen for one more second.
Oh.
You want to use, we've actually open sourced all of the code for chat LangChain, and so we want people to be able to leverage all the work that we've been doing. And this is one of the most common asks that we hear, is like, we want people to have a service desk-like interaction over their internal knowledge base. And so you can get the starter code yourself and bring it internally in your own organization to get started really quickly.
Awesome.
Do we want to, can I share screen to show chat LangChain too?
Yeah.
Okay, I'm back. Harrison, can you share your screen?
Yeah.
The wrong button, but I thought it'd be interesting to show how we also link to parent documents so that you can give people the context for what bit we are sharing, and then what the larger document is as well. So if you ask any questions here, and if you click on the, we highlight for you all of the sources that we retrieved to help answer this question and ranked it. And then if you even click on the zero link, can take you to, click on that, takes you directly to.
Which you won't see because I shared a window, not my entire screen, but it opens up a tab with this link. So.
Yeah, it shares the full direct source for the URL for where that bit was retrieved from. And we wired it up as well, that if you click on the icon for Lang Smith, we're big on emojis here. You can see the trace happening of what's getting retrieved, and this is Lang Smith. A lot of people here have had some familiarity with it, but it gives you full visibility into how this is being powered under the hood. In this case, it was not too many steps, but some of the more complex questions end up needing a number of steps to be able to respond to the user's questions. So we'll pause here. If anyone else has any questions, feel free to add them to the chat. But we're also available at any point too if you have more questions on RAG. I should add that we're going to do more of these webinars, and RAG seemed to be the topic on top of everybody's mind. But if there are other topics where you want to go deeper, if you found this useful, please let us know. You can get in touch with either of us, but I'm Julia at langchain.dev, and we'll hopefully have a series of information to help you all get started and become pretty advanced with using LangChain and LangSmith.
Awesome. Thank you guys for joining.